Good morning, everyone, or good afternoon, or good evening, depending on what part of the world you're joining us from. My name is Max Wright, and I help lead the Earth Observation for Ecosystem Accounting initiative within GEO. And I'd like to welcome you all to our side event, Making Statistics Geospatial, Mobilizing the GEO Community to Support Ecosystem Accounting and Data Interoperability. This has been a tremendously exciting year in the world of ecosystem accounting, with the ratification of the SIA and countries around the world beginning to develop their ecosystem accounts and environmental accounts. We can go to the next slide, please. We have a great event scheduled today. We have presentations by some of the world's leading experts, including Alessandra Alfieri, Chief of the United Nations Statistics Division, SIA, Ken Bagstad from the United States Geological Survey, Eva Evitz from the European Environment Agency, and Francois Soulard from Statistics Canada. Each of the presenters will be giving a brief presentation that highlights how the relationship between ecosystem accounting and Earth observation. Then we're going to have a demonstration of the Aries for SIA platform that can be used for developing ecosystem accounts. And finally, we'll have a panel discussion with all of our presenters. The objective of this session is really to mobilize the GEO community around the implementation of the SIA. With the new ratification, the EO3A initiative has changed or has created a shift within our work program to better support that implementation. And we invite the GEO community to work with us in making ecosystem accounts a part of the national statistics that countries use for decision making. And so with that, I'd like to move to our first, before I move on, excuse me, I should say, throughout the session, if you do have any questions or comments, please feel free to put them in the chat or in the Q&A session. We will have some time for clarifying questions after the presentations, and we'll have time for a more in-depth panel discussion at the end of the presentation. Please note that our session is two sessions on the agenda, but it's actually one continuous session, and we'll be going throughout the entire process. So with that, I'd like to pass it off to our first speaker, Alessandra Alfieri. Alessandra, to you.
Thank you. Thank you very much for the invitation to participate in this event. I think it is indeed quite timely to have this conversation now with the geospatial community. Now that we have, as Max has said, the statistical standard for measuring ecosystem, the challenge is really its implementation. And we in the statistical community will very much like to develop a partnership with the geospatial community to try to assist countries and leverage the expertise to compile these accounts using Earth observation. So I think that, it couldn't have been a better time to organize this type of meeting. So how did the whole SEA discussion start? I will just give a brief overview of where we are and what we plan for the implementation. So it all started basically recognizing that the GDP and the economic accounts more in general do not really reflect nature properly, in the sense that depletion and degradation of natural resources are actually not taken into account. And for example, cutting a old growth forest actually counts as production, but it does not have, let's say, any negative values associated to it. So GDP is a great indicator for measuring economic performance, but there is a need to actually make nature more transparent. And this started the whole work on the SEA, which originally was very much focused on kind of adjusting GDP, but increasingly this thought process has changed, and the idea is really to develop a system which is at the par with the system of national accounts, which measures the economic information for measuring the environment. And increasingly also we have taken an ecosystem approach in measuring the environment. Next. So the adoption of the SEA actually created quite a bit of I would say, support and at the policy level. So our Secretary General actually tweeted saying that it is now time to correct the glaring blind spot in how we measure economic prosperity and progress. So, and he just released the Common Agenda a month ago, which is basically a manifesto of his re-election. And he identified, I think, 9 priorities, and one of them is really going beyond GDP. And in particular, he actually mentioned, and here I'm quoting, I urge member states and others to begin implementation of the SEA ecosystem accounts. So we do have all, let's say, the political support and the political will to really move forward in that direction. Next. So what I mentioned before, we have the system of national accounts which measures the economy, and now at the par of it, we have the system of environmental economic accounts, which is kind of consists of 2 volumes. The first volume, which is the central framework and looks at how the economy uses the environment in terms of extraction of natural resources and return of residuals back to the environment, and look at environmental assets in terms of basically individual assets. So we look at timber, at fish, and water. But what the ecosystem accounts does, and this is really a novelty and really a game changer in the way we see things, is really taking an ecosystem approach. Is a especially explicit model framework which actually measures the ecosystems and their contribution to the economy and well-being. And then we have different subsystems that have been developed to develop more like a common language and a common understanding with different community. For example, with the hydrological community for water, with energy, agriculture, forestry, and fishery, measuring sustainability of tourism. And then we are working now on the ocean and biodiversity. Next. So what is the SEA ecosystem accounts? We basically have a system of accounts that consists of flows and stocks, and this is basically the whole principles behind the accounting system, which define, basically, we measure the ecosystem extent, the ecosystem condition, and ecosystem services in both physical and monetary terms. So the ecosystem extent basically here consists in identifying the area of different ecosystem classified by ecosystem types. And here we use the IUCN global ecosystem typology. And this basically, this type of accounts are very much reliant on Earth observation. So here we very much look for further collaboration with you. And the ecosystem condition accounts, they measure basically the health of the ecosystem, again, by ecosystem types, through a set of variables or indicators. Most of them are also spatially explicit and again, based on Earth observation. And that can be eventually aggregated also into indices to get a kind of a summary situation of the health of the ecosystem. And then we have the ecosystem service flows, which are actually generated by the ecosystem assets. And here the ecosystem service, we look at provisioning, regulating and cultural services. And what we have done is developed an agreed list of about 25 ecosystem services with a clear definition and classifications. So, and what we are now trying to do is providing guidance on the measurement and the models to actually be used to compile this ecosystem. And we have developed some biophysical guidelines that serves more as a kind of a reference point. And then from the physical accounts, then we go into the monetary accounts. So we value the ecosystem service flows and eventually the assets through using net present value techniques. And here, in the evaluation is consistent with the principle of the system of national accounts. So we use exchange values, and this allows full integration between the let's say the environment and the economic accounts, because we use a similar set of rules, accounting rules and classifications that allow this integration. Next. So basically our vision here is really to develop an integrated information system on the environment, which of course links to the economy and provides a basis for supporting monitoring framework, for example, in the context of the ecosystem restoration, especially in the conventional biodiversity. We are working very closely with the CBD in the monitoring framework, which is currently being discussed, and making sure that the indicators are actually aligned as much as possible with the SEA. Of course, the Sustainable Development Goals, a lot of the indicators that are part of the monitoring framework of the SDGs can be derived from the SEA, and we are working with countries in implementing this. And of course, also the climate change, in particular now that there is this interest in moving towards nature-based solution and nature-based measurement, and the UNCCD as well. Next. So now, I mean, the hard work starts in the sense that we have the standard, but we have to move to implementation. So we have developed an implementation strategy. Our objective is to have at least 60 countries implementing at least one account of the ecosystem accounts by 2025, depending on countries' priorities. And the objective here is really to mainstream the production process of selected ecosystem accounts within the national statistical system. So not to have just a one-off type of exercise, but to have it integrated. Even if we use Earth observation data, the idea is to enable countries to be able to reproduce these accounts on a regular basis. And also mainstreaming this, the results that we obtained into the national and subnational policies. And this, I mean, as I mentioned before, the objective is really to support the different monitoring framework, and then have the SEA, EA being kind of the tool for supporting reporting into national biodiversity strategy and action plans, voluntary national report, the SDGs, and the national determined contribution. And then, of course, the dissemination of these ecosystem accounts through global data sets. So using either global data sets or having national data where they are available. Next. So the approach is very much having a multi-stakeholder engagement. The National Statistical Office is not, let's say, equipped to actually compile this type of accounts on its own. So the idea is to bring in together people from different communities, including mapping agencies and from line ministries, to basically using the SEA as an overarching framework, and to develop these accounts in a collaborative way, and building on the expertise that is available in the different communities. And of course, using a flexible and modular approach. So the idea is in choosing also the priorities is looking at the policy demand as well as data availability. So start to have some kind of quick wins to put some results on the table, and to keep the policy community being engaged. So even if the data is not perfect and is experimental. And use it a tiered implementation. What we mean here with tiered implementation is that we start with using global data sets and models. So developing to start to have kind of a tier one type of accounts that then need to be validated, and we need to basically bring all the different stakeholders at the country level to have a conversation with them and improve on this tier one type of accounts that are generating using global data and global model, using national data sets, and increasingly have the these accounts being nationalized so that they can be actually reproduced at the national level. Also using a regional and sub-regional approach. I mean, there are countries in different regions that are more advanced than others. So how can we actually leverage the expertise that is already being developed in some of the countries to export it, let's say, to other countries? Also because most of the time the problems or the issues that are encountered at the regional and sub-regional level are very similar. So they basically develop this some kind of south cooperation so that they can work together and learn from each other's experience. Next. So basically, here what we are trying to do, the activities that we are trying to do to support the implementation are of course building capacity at the country level through the development of guidelines and material that can support the compilation. Strengthening collaboration, and this works both at the national level but also at the global level. It's quite important that we build partnership and collaboration with communities that have expertise that are not available at the statistical, I mean, that the statistical community does not have, as in this case with the Earth observation community. And of course, communication and advocacy is quite important because we need to actually reach out to different communities to make them understand of the strength of the SEEA and what's the value added in really using an accounting approach. And I left the last box, this data and tools, which I think, I mean, Ken is going to talk about this, but I think making, having this tool like areas for SEEA that we have developed that would allow countries to have some kind of initial estimates on the accounts will definitely help in moving the agenda forward. Next. So why is the SEEA? So the idea is really to make, we say make nature count, so to make it really explicit, the contribution of the of nature, of the ecosystems to the economy and well-being. Using a common language, this is quite an important contribution of the SEEA in the sense that basically what the SEEA is an organizing framework that takes the information which is available from different data sources and put it in a, organizes it in a way that it's also and using a language which is familiar not only to the environmental community, but also more broadly to the people sitting in the finance ministries or economic and planning ministries. Standardization is important. I think it's quite important that we move towards having data that is generating using agreed method, agreed definition, and agreed classifications, so that we obtain comparable statistics over time and also across countries. The SEA is also quite key in catalyzing collaboration because it is a framework which covers different disciplines. So the it does provide a way to for different stakeholders to start working together and to share the data, but also understand what the uses and application of the SEA accounts are. And also it is by the way it is designed is really an integration framework, and it provides a framework for deriving the indicators that especially that are at the intersection between the economy and the environment, and as such then supports a lot of the discussion on the monitoring framework that that are going on in at this time, including the SDG and the post-2020 global biodiversity framework. Next. So basically just last slide to say that we carry out every year a global assessment, that there are quite a number of countries that are already compiling at least one module on the SEA. There are about 89 countries that are compiling one module of the SEA central framework. We have different shades of blue depending on whether it is a regular compilation, which is the darker blue, and the lighter blue means that basically there was at least one account that was compiled in the last 3 years. And then we have 34 countries that are compiling ecosystem accounts. And I think 27, but I think even more are planning to do so. So our objective is really to scale up the implementation in the next few years and develop partnership with the different communities to achieve the goal. Thank you.
Great. Thank you so much, Alessandra, and congratulations to you and the entire UNCIA team on the statistical standard. And as you say, now the work really begins. And so with that, I'll hand it over to Ken to talk a little bit about data interoperability. Ken, over to you.
Thanks so much, Max, and thanks for the opportunity to speak today. I'll be speaking on behalf of a number of colleagues in this work, including folks from the UN, Alessandra and her team, as well as some of my folks from the Bass Center for Climate Change, who've been working on a tool called Aries for SIA, which I'll be demonstrating after the break. One of the things we did in conjunction with development of Aries for SIA was to put together a strategy to specifically look at how we make data and models for SIA interoperable. This is a question certainly relevant to a lot of GEO issues, but very much GEO for EA. And interoperability is really a core challenge for us. The FAIR principles are probably familiar to most of you. I borrow a quote from our colleague Francois Soulard, who's going to be speaking later in this session, that really gets to the point that interoperability is one of the more difficult parts of FAIR, but a really essential part of FAIR. Next. So what is the status quo of interoperability? I would argue that currently we're not doing very well at it in most cases. In the ecosystem accounting world and many other fields, scientists from countries with the resources and the scientific training and the data can do great one-off work. Modelers often don't know another way. This is sort of how you learn in grad school, and often your skill set doesn't always evolve beyond that for many scientists. Capacity development is challenging, especially in the global south, and this is a real equity issue. And finally, next point, certainly beyond the global south, it's a problem for the repeated production of natural capital accounting data everywhere. Accounts need to be reproduced over time, as Alessandra described, and ideally we would have a way to just press a button and update accounts as new data become available, and in many cases we haven't had that. Next. So what could a different vision look like? And this is a vision that's been promoted by many folks, including some of my colleagues on this call and others. But what we came up with for our interoperability strategy is we would like for SIA accounts and related indicators to be rapidly recompiled as new science emerges. When a new technique or method becomes available, we'd like to be able to do a better job of measuring these indicators and to be able to recompile them using those new methods. We want to be able to update trends as new data become available to keep a long time series of how our Earth and its ecosystems are changing. And we'd like to be able to do good international comparisons and at the same time to be able to do country-specific customization when countries have their own data and modeling approaches that they want to use. At the end of the day, we want to be able to move high-quality information from scientists into the hands of people who make decisions as quickly and transparently as possible. Next. So we released at the beginning of September this interoperability strategy, which you see the link there for. And in it, we describe the current state of interoperability and our vision for the future. I just gave the brief overview of both of those. We describe the roles and responsibilities of different groups to help us get there, and that includes data providers, modelers, and institutions, including national statistical offices, but also mapping agencies, space agencies, many different institutions involved in the GEO community. How we implement the strategy, and some key conclusions. So I encourage all of you who are interested in this topic to check out the interoperability strategy and to offer us feedback on it. Next. One of the key, really non-controversial elements of interoperability is that it requires common goals and standards. So we've made a lot of progress as a scientific community over the last decade on open science, things like data and code repositories, APIs, and statistical metadata. But the places that I think have been lacking so far are in consistency and machine readability. And we really need a way for computers to be able to read and automate these processes, which I'll demonstrate using areas for SIA a little bit later. There are two types of interoperability, syntactic interoperability and semantic interoperability. And with syntactic interoperability, we have common data formats and communication protocols. So we exchange data between computer systems by ensuring that there's consistency with how the data are set up and what kinds of communication approaches we're using. Semantic interoperability, by contrast, we're trying to make sure that a computer can really understand the meaning of the data that are exchanged and that it's reused appropriately. This, as you can imagine, is more complicated, but it enables us to get to greater automation in data and model reuse. And this is a vision we've really been promoting and implementing with Aries and Aries for SIA. Next. What we do here, we have three key pieces. There's semantics, which is a consistent description, consistent metadata for different data sets and different model elements so that a computer system can know that they're indeed interchangeable or not. And the blue box I have at the bottom for all of these is basically where we need to go beyond the state of today's status quo. Our semantics don't need to be something that a typical scientist uses, but a typical scientist does or doesn't build them, but a typical scientist does need to be able to use them to be able to describe data and models for a computer system to be able to link together. Second, we need open linked data. And again, this goes beyond the current state of data repositories. The data need to be semantically meaningful. It needs to be in web accessible formats. And third, we need an ecosystem of open and linkable models. And we envision a Wikipedia-like system where there would be sharing and coupling of these models. We need to think about, for the modelers out there, we need to think about how we code them, making them as modular as possible, building in the documentation for that enables code once it's run to have reports automatically generated, and to specify the conditions under which a model should be run, whether that's a part of the world or a spatiotemporal scale, for instance. The fourth thing that links these all together is open source software, which again I'll demo a little bit later. Next. So what are the roles of these stakeholders? I alluded to this earlier. For data providers, we want to have folks agreeing on and providing data using common formats and hosting protocols, and we want to be able to have those be consistent and machine readable. For modelers, we want to use modeling practices, as I mentioned, that make models easier to link, reuse, and document, and using consistent semantics. For national statistical organizations and other institutions, we want to be able to maintain interoperable data and models persistently over the long term. And the question is, how do we as a community envision incentives that get us there and move us past the status quo? Next. Finally, and I would argue one of the most critical pieces is that interoperability has to address the human element. We've been working for a long time on technical solutions. We think they're good technical solutions. And there's on the left side of the slide, there's a blog post that we developed and put together for GEO that talks about this and links to the interoperability strategy. There was another blog post that came out about 2 weeks before ours by Stephen Ramage. And at this point, the title is really all you need to, it tells you much of what you need to know. People are essential in data interoperability, and solutions need to be user-friendly, equitable, and community endorsed. And without that, we're not going to get to where we need to go. So this is part of why we're excited to talk about and promote this strategy and to find ways together to implement an interoperability strategy for the SIA community. Next. And finally, our next steps, we are looking at pilot testing. We're pilot testing already in a number of different countries, engaging with different stakeholders. We're certainly excited to engage with anyone on this who is interested in helping advance SIA and data interoperability more broadly. Thinking about governance for this community, we've been working with the UNSD and others on how we do this, and improve training and capacity building. And again, what we want to come to here is shared vision, common standards, and serving the SIA community's needs. So with that, I will wrap up, and thank you so much for the opportunity to speak today.
Great. Thank you so much, Ken. It's a very inspiring vision that you present for us around data interoperability and rallying the community to make these ecosystem accounts a reality. And so with that, I'm going to pass it over to Ava, who from the European Environment Agency, who has been working with some of this data and starting to compile some of the data that's necessary for ecosystem accounts in Europe. So Ava, over to you.
Thank you, Max. So good afternoon, everyone, or morning, indeed, depending on from where you are joining in. So yeah, so the European Environment Agency is one of the agencies of the European Commission. It is located in Denmark, in the beautiful capital of Copenhagen. And indeed, we are working basically very strongly with the European Commission together. We produce data, we analyze data, we assess data, write report for them to be able to monitor if European policy making makes sense, if it works. And for those accounting, working with data is of utmost importance. I'm very happy to be here today and talk to you very shortly of what we are doing. But before that, a short introduction on the EU INCA project, which is basically a project, or was a project, on accounting for national capital and ecosystem services. So indeed, it is a project which is a EU-wide project. It is a cooperation between ESTAT, which is a Eurostat of the European Commission, so that's the statistical service of the European Commission, as the EEA, the European Environment Agency, the DG Directorate General for Environment, the Joint Research Center, and the DG RTD, which is Research for Development. So indeed, we worked a lot together with researchers and policymakers to develop an EU ecosystem accounting system. And this system is now more or less developed. So we have set down the basics for ecosystem extent and condition accounts. We have set down the basics for ecosystem service flow accounts, and also some valuation of benefits from natural capital, although I must say this is not my expertise, so please don't ask me too much questions on valuation, so from monetary aspect. There was a pilot phase of this project which concluded in 2020, but the work goes on, and the current focus is extension and implementation of the accounts, accounting tools, infrastructure, and assessments we have developed. Next slide, please. Yeah, so just before we dive into the more exciting stuff, just some key policy developments at the European Union level. Some of you must have heard of the new EU Green Deal. This is basically a new policy direction from the European Commission, which tackles climate and biodiversity crisis, addresses many components of economy and society, for example, the farm to fork strategy. Then we also have now the implementation of the Lulucf Regulation. Lulucf stands for Land Use Change and Forestry, which addresses the decrease greenhouse gas emissions and increase removals in the Lulucf sector. In the meantime, our statistical division, so the European Commission Statistical Service, Eurostat, is working now with a task force on a proposal for an ecosystem accounting module to be implemented in EU environmental accounts regulation. And if this becomes indeed a regulation, then European countries will have to start report. And we are very happy and looking forward to this, because we are very happy to support countries with data derived from Earth observation. Indeed, and that means that statistical offices in EU member states will have to develop their accounts or basically report on them. And indeed, they will have to, or the Commission now is working on ecosystem extent accounts, so to define what are the ecosystems that has to be reported on a regular basis, ecosystem condition accounts and ecosystem service accounts. So here in for the last one, for example, pollinators are one of the ecosystem service accounts that is looked at now. Next slide, please. So to do this, to support the European Commission with data is not enough, because geospatial data is locked in a geospatial format, and there is a handful of people who can open a spatial data set. And we need to convert Earth observation data into meaningful and transparent messages. And we have to do it in a way that we have to understand where impacts occur. We have to address the magnitude of these impacts, and we have to be able to address these synergically. So in an integrated accounting system or assessment systems, so that effective nature restoration plans can be designed. But there is a good news. The good news is that there is an ever increasing set of observation data. More and more data sets are freely available. For example, via the Environment Agency, we are running the Copernicus Land Monitoring Service. Sorry for the abbreviation. CLMS stands for Copernicus Land Monitoring Service Europe, using the Sentinel satellites. And we are looking into using these to convert these into extent and condition accounts of ecosystems. But there is also a but, there is always a but. And the but is indeed that it's not enough to have these ever increasing huge amount of data. They need to be indeed translated into meaningful and transparent messages, so that worsening or improving conditions can be assessed, right? And the second big problem is that the information is scattered. It's very difficult to find the data and access the data, and it relates both to Earth observation data and derived indicators. So there really is a strong need for an operational analytical environment for experts. Next slide, please. Yes, so what we are doing now is indeed, we have quite strongly worked on a system, an accounting system, which I'm going to talk to you about now very shortly. I will be short today, so I hope no one get bored. And this system indeed, which we have worked out, follows the FAIR principles. So we put a lot of effort into findable data and findable results, that the results are accessible, such in a very fast, effective way and on demand. Also that our data are interoperable, so they are quality assured and controlled. So I'm very happy that Ken just talked about interoperability, because indeed machine-to-machine access is not something that very frequently looked at now, but this is extremely important for interoperability indeed. And also that data and results are reusable. This is because we have to be able to report frequently, and we are aiming at, actually, with our high resolution temporal and spatial resolution images, to be able to report with an ever increasing frequency. Now we are aiming at every 3 years, but we are already going down to yearly reporting, actually. But that all can only be achieved if so we can only translate geospatial data into messages that are meaningful for a policymaker, or for those stakeholders who can't actually access geospatial data if we follow the FAIR principles. Next slide, please. So just to be a bit funny here, and I swear that happened. I Googled once, I think it was last year, searching for data, and the very first link, very first link came out, which I put in the presentation here, where in this study they have analyzed that employees in a company on average lose 2 hours a day while searching for the data. And this many might think that this is peanuts, but this is an incredible problem. Even and with an increasing amount of Earth observation data, we have increasing amount of integrated assessments. So the data needs to be structured in an interoperable way. And we have worked on this. We have our spatial data infrastructure at the European Environment Agency, which has actually a searchable online interface with beautiful metadata catalogs. And there the data we produce, gather, process are accessible for everyone to basically explore it, but also to download it and use it. Next slide, please. So using the spatial data infrastructure as an input, we have worked out our integrated data platform. The integrated data platform, what we are using at the agency is basically data cubes technique. So what we do is basically in principle very simple. We take the geospatial data, each one of them, let it be raster or vector, whatever format, wherever, and convert them all to huge, very big tables. And these tables make actually the locked geospatial format converts that format into analysis ready formats. And these big tables, these big databases are stored on the cloud. And hence they are open and anytime accessible to put them together into various data cubes. And now we have, and a data cube is basically just a big database, but such that the data that is in it, its quality, it follows the FAIR principles, can always be found back. And once we have all these data in our integrated data platform, we know where they are, how they are linked together in a data model. We are now much faster and much more efficient to derive accounts. And indeed, we have lots of accounting data cubes. We're looking at land accounts, ecosystem extent accounts, soil sealing, land recycling. We're looking at riparian zones, coastal zones, urban areas, landscape fragmentation of protected areas, and a lot are coming up, with which we are now analyzing these data and then support the European Commission. Next slide, please. So how do we do this? Once we have our data cubes processed, we are publishing dashboards, and these dashboards are interactive, so we can have maps in those dashboards where our policymakers can zoom in or zoom out. We have lots of bar charts, figures, statistics in tables, and all these with a live link access the databases, so the big data cubes. And these dashboards also allow the user to download the data behind. Hence, if someone wants to address how much is land take or soil sealing in a country, let's say Germany, this can be queried in the database. It can be mapped on demand. Statistics can be presented or displayed on screen. And this data then can be downloaded both as a database or as an image what the user sees online. And this sounds, I guess it sounds to many of you very simple, very, yeah, okay, what's news? It is huge news because just one anecdote, and that is actually my last slide for today. Each time I talk to policymakers and tell them about high resolution data, very frequent, beautiful colors, 10 meter, they say that's great, Eva, but please give us a table. It's a table we can work with. We can't work with the raster data set. So indeed, next slide, please. What we are doing is producing accounting dashboards, which are all published on our website. And I have put here some links, but in reality, there are so many now that we are thinking of a dashboard to produce, to collect the dashboards that they can all be accessed at one central place. So this was my last slide. Thank you for your attention. And I hope it was interesting. And if there are questions, obviously I'm staying and I will be able to answer.
Great. Thank you so much, Eva. And just really great to see all the awesome work that's coming out of Europe around ecosystem accounting. So what we're going to do now is actually take a little bit of a shift from the agenda. And so we've been focusing a lot on this data and interoperability. And so now we're going to have a bit of a demonstration from Ken, who's going to demonstrate the Aries for SIA platform, which is a platform that builds on a lot of the concepts that we've been discussing in this section to directly support countries who are compiling accounts. So Ken, with that, I'm going to hand it over to you.
Thanks so much, Max. So I'm going to be showing Aries for SIA today. And can you see my screen?
Yes, we can.
Okay, great. So first of all, Aries for SIA is available at this website, publicly available for anyone. And this website describes how to download and use Aries for SIA, what it does, the interoperability strategy. There's quite a bit of material on here, so I'd encourage folks to give this a look as a starting point. But what I'm going to be demoing today is the web browser interface of Aries for SIA. And our intent here, as Eva just told us, oftentimes people want the tables. They want to be, not everybody has the ability to do geospatial work themselves. So we need faster and easier ways to access data and to bring them together. And that's really part of what Aries for SIA is aiming to do. What we have with Aries for SIA, as you can see, is a web interface that lets us go anywhere in the world, and much of the functionality initially is similar to all sorts of web mapping tools. But what we can do is we can pick a part of the world. In this case, I'll choose Kenya. We can also pick a river basin or administrative regions at different levels, choose a spatial resolution that we want to use, and choose a time period that we want to use to compile accounts. Then all we need to do is select which accounts we want to compile. And we have choices here for ecosystem extent, ecosystem condition, ecosystem services, and physical and monetary terms. I'll just get started on demoing one of these, and then I'll talk a little bit more about what Aries for SIA does when a user starts a session and requests the compilation of an ecosystem account. So in this case, I simply checked a box for compiling an ecosystem extent account. What Aries does is it will go out onto the web and look for models and data sets that could be used to compile, in this case, ecosystem extent, but they could be models of ecosystem condition or services, whatever the user needs. It'll look for the models that are available, and there's a global model available for all of the content within Aries for SIA. So any of these can run in any part of the world. But really, the intent is that we can have users contribute models that are specific to particular parts of the world, particular contexts, spatiotemporal scales, etc. And so if we had an ecosystem extent model, for instance, that we knew worked better than the global model for East Africa, Aries for SIA, the artificial intelligence that underlies it, would be able to pick the most appropriate model for this part of the world. You can see once the model's been selected, Aries is assembling data sets. And again, these are pulled from the web. data sets that are semantically annotated. And these aren't data sets that are hosted on my computer. They're web-hosted data sets that Aries is pulling together and using to map ecosystem type. Now Aries is doing the time series compilation from the years 2012 to 2015. And what it's going to produce in the end is both maps and tables. The maps we can download. You can download these as a GeoTIFF for later use. The table is going to come up in just a second here, and it's going to show the change in ecosystem type over the accounting period that was specified by the user. The other thing that Aries for SIA automatically puts together is a report that describes what data and models were used, the underlying methods, the results that come out of this, and any caveats and references. So the report gets automatically built. We get the data sources that were used as part of the process, a list of all the data sources pulled from the web, and a data flow diagram, which shows each of these boxes in this interactive interface can be clicked on, and whether it's a data set or an algorithm, you can see very transparently what's happening at each step along the way. So at this point, we're just waiting on the compilation of the table. I'll mention that there's a user guide that's accessible. There's also the ability to access it in different languages, and you can see now we've got the table here. So this is the ecosystem change we get for Kenya from 2012 to 2015, and we can download the data as an Excel spreadsheet for further analysis. So this is the completed model run for Ecosystem Extend in Kenya. If we want to keep running models, we can simply choose another one of the models to run, and I could, for instance, add a model of soil erosion control, sediment regulation, and similarly, Aries will go out and collect those data sets, run those models, and report them. So this is a way that we can get preliminary accounts. Now this is at coarse resolution, 2 kilometers, but preliminary accounts compiled, as you can see, in a matter of minutes. And we could envision countries around the world compiling these, in a matter of hours to days, rather than taking months, many months, which for many countries, these are complicated to put together and difficult. So this would, in the past, be a really painstaking effort, not achievable in many parts of the world. But with Aries for SIA, we're able to do this. One of the other things that we've developed is a set of models to support several of the SDG and CBD indicators. And this isn't a comprehensive list, of course, but we're essentially showing that some of these models we can similarly code in Aries in a way that countries can quickly calculate and report on those. So if I click on one of these additional SIA-related indicators, it will appear in the interface and with a checkbox, and I could add that to my calculation as I want to. Aries for SIA, the interface here, as you can see, is in English, but we also have interfaces available in Spanish and French, and one coming in Portuguese. So we have the ability to, and we'll be doing this for additional languages as well. So for countries where English isn't the primary language, the ability to access and use the Aries for SIA Explorer as well. Just two other things I want to talk about. One is what we do with the data and models to get them to a stage where they're interoperable and can be easily ingested within Aries. And then finally, I'll circle back to what's coming next in Aries for SIA. But as a next step, I'll describe sort of how this differs from your sort of standard open and data and models. Many of us are used to seeing our data stored in data repositories at this point. Of course, as I said during my interoperability presentation, we want to make sure that those data are machine readable and semantically meaningful. So what we do is we have those data available through web coverage services, often using a geo server, but other technologies can be used too. And then we semantically annotate the data. So we give them semantic meaning. There's a second interface for ARIES, which is more technical in nature. It's really designed for scientists to use in order to contribute new data and models. And all we do there is we have some commands to ingest new data sets and to semantically annotate them, and to do so in a way that that provides all their provenance information. So that when we have our modeling workflow, for instance, and we click on a particular data set, we get all the information about it. This is an example of a soil organic carbon data set coming from ISRIC that we have all our relevant metadata for. So for data, we want to make sure that those are available in machine accessible formats and that they're semantically annotated. For models, it's a similar process. And we see here's the soil erosion control physical supply table. So how is soil erosion control changing in Kenya over the same time period? So we can see now we've got an expanded report where we have ecosystem extent and soil erosion modeled for Kenya. Going back to what I was just talking about how we make our models more accessible, it's a similar process there. Many scientists are contributing their models in code repositories, and that's great. That's a step forward for open science. But what we want to do next is make sure that they're, again, machine accessible and that they're semantically meaningful. So we have any type of Git repository can be opened and run from within the ARIES modeler interface. It can be customized, and we can specify when and where a particular model should be run in what parts of the world. So for instance, if you have a model that works well for a particular climate zone or ecosystem type, you can specify that, and that will be usable within ARIES. So we really are encouraging folks to, especially data providers and modelers, to learn how to use ARIES, learn how to use the semantics behind it in a way that makes data interoperable and accessible to users in an easy interface like this. I'll close this demo out by just mentioning briefly what's coming next in ARIES for SIA. Some of the key things are, of course, adding more content to the models that are available. Right now, we have models for ecosystem extent using the IUCN's global ecosystem typology with about 30 ecosystem types. We'll be expanding that to probably about double that number, as well as ocean ecosystem types. For ecosystem condition, we've started out by providing a series of options for forest ecosystem condition indicators, things like NDVI, leaf area index, net primary productivity, and fragmentation, all of which can similarly be calculated. But we'll be adding more metrics for other ecosystem types, so the ability to calculate ecosystem condition for aquatic and wetland ecosystems, croplands, urban areas, etc. Adding more ecosystem services to the list. This is our current list, which is a fairly short one. We have crop provisioning, crop pollination, carbon storage, soil erosion control, and we have a model of nature-based tourism on the way, and one for water supply as well. Potentially more SIA indicators could be included if the SDG community or other geo initiatives find this approach valuable. It's the sort of thing that we can build similar interfaces for other types of calculation. And we're going to be doing, we're working right now on a series of baseline global model runs for ARIES for SIA that are going to describe basic global land and ecosystem accounts, ecosystem services accounts, etc. Finally, we're going to be adding more flexibility to how results are aggregated. Right now, the results are provided. These tables you see are provided for the whole nation, but the ability to provide them by administrative subregions for protected areas or for river basins, to calculate them for all years in a time series rather than just the starting and ending year. And finally, the ability to add custom data more easily. We recognize that Aries for SIA is a powerful approach, but that the modeler interface requires more training and more expertise, and it's a smaller subset of people who can use that. So what we envision going beyond the interface you've seen so far is that if, for instance, we had a data set for, well, land cover is a very common one, that almost every country has a preferred land cover data set, that if you have a data set for your country that you want to use in place of whatever the data set is, you'd be able to drag and drop that from your computer into this land cover line in the interface to specify what the numeric codings of land cover entailed, and to have Aries recompile the models using the local data. And of course, that's easy. That's even easier for categorical data if you have your own elevation data set, your own climate data, etc. There's even less custom encoding that needs to happen for those. But the idea that we could customize models using national data and a drag and drop web interface is part of one of the things that's coming for the future of Aries for SIA that we're very excited about. So Aries for SIA is being used already in a number of different countries, but we're excited to see it used more widely to continue to improve the capabilities, and particularly the data and models underlying it, and to move ahead on this broader interoperability agenda for the SIA community and beyond. So I think I'll wrap it up there, and thanks so much for the opportunity to present this today.
Wow, great. Thank you, Ken. That was really cool. It's really amazing to see, the advances that have been made with the series Aries for SIA platform, and how you're kind of putting a lot of these principles into practice through the Aries platform and making this data and these models available. So thank you so much for that. And I'm sure that we'll be circling back during the discussion section to really dig in a little deeper. Now I'd like to shift to our colleague Francois Soulard from Statistics Canada to provide kind of the country perspective from the people who are actually compiling these these environmental accounts. And so with that, I'll pass it over to you, Francois.
Hello all, and thank you to the organizers for the flexibility with and readjusting the agenda. So as Max just said, from the perspective of the National Statistics Office, the use of Earth observation and the importance of data interoperability for ecosystem accounting. Next slide, please. Can skip to the next immediately as well. So I'm happy to announce that we recently were awarded a significant, for us anyway, funding to do what we call a Census of Environment. And we're talking here about $26 million over 5 years. More importantly, though, it's an annual project that will be ongoing for the foreseeable future. Next slide, please. So we have proposed this. We have a co-sponsor, which is the Environment and Climate Change Canada. And we are working with several other science departments, federal science departments here in Canada. And I mentioned this here because last time I presented at GEO was a couple of years ago, in a session also organized by Conservation International. And I had mentioned on the importance of working with the data providers, especially from the Earth observation community in order not to try to replicate what good science is already done in the departments, but capitalize on it and in some case, use products that are derived from these data or work with them to get the data we need, and more on that later. But the idea here is for us to bring information together that exists, but also create new information where data is missing, to compile information on ecosystem assets and the flows and the services and the users and the benefits of these uses. Next slide, please. So the Census of Environment it contains 3 components. The first is we're going to be building a register of ecosystem assets. National Statistics Office have registers. It's a common tool for us to do our work. For example, we have a business register that allows methodologists to draw samples to do surveys of the business world, but we don't have a register of ecosystems yet. Once we have one, it will perhaps help conduct surveys if we want to include ecological variables in the survey frame. But more importantly, it will allow us to do a good delineation of the ecosystems and also do the work related to assessing, estimating, modeling the services that we can then attach or link to the users. The second aspect of the census is to do profiles of environmental statistics by drainage area and by ecological area. We've done those in the past, but now we'll be able to keep them maintained and to upgrade them. But I think the most important part for me is the next item, which is the building of the integrated environmental economic accounts. And that's going to be a core focus of all of our efforts. Lastly, and I won't spend too much time on that, but it's to create a portal where users can have access to the information, but also to analytics, advanced analytics to do their own research and own work in a protected environment. And that will, of course, require that all of the data in there is interoperable. So all of this will serve the use of creating what you see on the left-hand side of the screen, which is the ecosystem services logic chain. We need Earth observation information to account for ecosystem type and extent and change over time, but also of course, the conditions of these ecosystems. And we need Earth observation to also model the services and better understand the supply factors. Then, using that information, we integrate it in huge amount of data that we have on society within the National Statistics Office to understand the use of these services, understand the factors that affect their use, and then all of this leading us to work on the reporting and the indicators development and applications in order to understand if the impacts that we have on the ecological infrastructure is a restoration or a degradation impact that affects services in the first place. So that's the logic chain. Next slide, please. So the register is a core data system. It's a national online spatially explicit geodatabase that integrates stats on ecosystems that are comparable through time and space. In order to do that, we need to acquire, integrate, and maintain ecological geospatial data from a variety of sources. And Ken just presented how ARIES allows the community to do that. So it'd be something similar to that, but more focused on national data, integrating the best scientific information from the science departments, but also from, where possible, academia and non-governmental organizations as well. And offering services to specific users that would be able to apply to have access to this geodatabase that takes place in what we call a protected B environment, and all of this being interoperable. Next slide, please. So from this register, we derive profiles. Like I said, we've done those before, but this funding, the census, the idea is to be able to do them on a regular basis and maintain them and probably expand the scope of them as well. So here we have on the right-hand side a map of land cover. So using satellite Earth observation, and product derived from an agriculture department actually generates these data. So just a few select categories. And below it, you have graphs of water yield. So again, that's based on Earth observation, but not satellite, but instead in situ Earth observation, stream gauging data, and we have time series for those. And we present it alongside information on pressures on the environment, and we have here indicators of agricultural pressures on water, the water environment. And we link it to socioeconomic information on the use of water, which is the graph, the bar chart you have at the bottom there, which comes from our suite of water use surveys that are run biannually here in Canada. So that's an example of a profile. Next slide, please. But more closer to my heart, dare I say, is the development of the accounts based on the central framework and the ecosystem accounting, a new standard. I think Alessandra probably touched on this, and Eva as well. I'm sorry I missed those presentations, so I won't get into it too much, but to say that these are core frameworks for us to use within the NSO, but also when we're talking to our other the other science departments, Agriculture Canada, Environment Canada, Department of Fisheries and Oceans, it's important for them to understand what our business model is and what position these framework what role they play in our data generation, and hopefully this will also socialize these frameworks, and hopefully they can also adopt them. And the same goes with academia. By partnering with academic research, we hope to have terminology and also concepts disseminated throughout that world so that we can better, more easily integrate that information within our own accounts. Next slide, please. So next, I'm just going to talk briefly about ecosystem assets, and next slide, please. I'm just going to talk a bit about extent condition and uses, and I'm going to wrap this within a minute or two. Next slide, please. So we've done this kind of work, accounting work in the past. We've worked on urban areas, and here we show an example of a map that integrates 1960s level data, boots on the ground, Canada Land Inventory, the first of its kind, and which led, fun fact, to the invention in Canada of GIS systems, because we needed a computer system to actually manipulate all of that wealth of data that came from the country. So that 1971 layer comes from 1960s, late 60s, and then we added to it Earth observation, satellite Earth observation information, and therefore we tracked the expansion of our 34 large urban areas in the country. And we have there a table with an opening and closing stock, which is an accounting table. Now, what we need is better information, better in the sense that we can account for not only natural and semi-natural classes as a single category, but we need to be able to break these apart. We need to be able to track forest, water, and so many other types of ecosystems through time. Right now, we don't have the understanding of the accuracy of these through time in order to be able to report change over time. We don't know. So this is one of the goals and the importance for us using accounting ready data. Next slide, please. Now, this is another type of work that we've done. Again, urban areas, population centers in Canada, we measure the greenness. As Alessandra might have spoken to, there's a condition typology and a new standard. NDVI is one of the indicators we can report on. So we track the greenness of 996 population centers in the country for 20 years. And that is one of the metrics that we use to report on the status of ecosystems in urban areas. These data right now were presented in an article, but on December 1st, they're going to be made available on our website, and a bit later on on our mapper, and the goal is a bit later on to have them actually offer it as a service. Next slide, please. And ultimately, and this is not our work, but we quote this work, but we're going to go there. You have on the far right side column estimated monetary values associated with various health products of pollutants due to pollutant reduction from trees. So we intend to do this work and do the monetization of this of the services generated by trees in urban areas. But that's just one example of where our evaluation work will lead us. Others have done this kind of work. It's possible. It's not without its issues, but of course we got to bring that forward. It's crucial we do that. Next and final. Why National Statistics Office? SIS, an article was released in Nature last year that explained why. So I'm inviting you to go and check this out. But basically, is that data is our bread and butter at National Statistics Office. We already report internationally. We are comfortable in doing this kind of work, so it makes sense involving us. And 3 key messages I'd like to finish on. First, that accounts are systems level solutions that can allow us to incorporate nature in decision making. That's a big gap in Canada and everywhere else, I think. NSOs are in a good spot to help do this work, reference to the article on the left. And finally, EO is increasingly important for NSO, but there's just so much of it. And there is just so many data streams that we can capitalize on. And in order to avoid duplication to the as much as possible, we want to use accounting ready Earth observation data. Let's try to work together, and ideally you can provide us with information we can integrate into our accounts without us having to work our way up the stream of the data production from the satellite downward. So thank you for listening in, and back to you, Max.
Great. Thank you so much, Francois. And yeah, it's great to see the work going on in Canada, and congratulations on making having the budget to develop these to really develop these environmental accounts. And yeah, it's just a great step forward. Now, we have about 30 minutes left in our session, and it looks like in the chats and the QA, we have some lively discussion going on. So I'd like to invite all the speakers onto the stage. So if you could turn on your cameras for us. We're going to open up to a bit of a discussion section to go through kind of some of the topics that have been discussed here and to answer some of the questions in the chat. For those participating, feel free to either ask your questions in the chat, or if you'd like to speak, if you prefer to speak, you can raise your hand and we'll call on you. And we can kind of start from there. I may start with a very broad question just to set the stage for our presenters, and it's about the barriers and opportunities of EO data. I think across all the presentations, this was touched on in some way or another. It's like, what are the current barriers that are preventing EO data from being applied for ecosystem accounts? And also, what are the key opportunities? What are those crucial data sets that can really advance countries who are starting to develop accounts? What is that baseline that, if we had X, then so many other things would be easier? And so, I'll let any of the panelists who'd like to jump in just kind of give their initial thought, and then we'll move into the question and answers from the audience. No need to be shy.
Well, I'm happy to jump in. In order to allow us to move forward on this Census of Environment and to capitalize on existing data processes that exist elsewhere, I developed institutional arrangements with the departments that can best provide us with accounting-ready Earth observation data. And the best way that I found this, that I thought would be useful, was to actually transfer to them salary dollars so they can actually embed individuals in their processes, and these would act as, if you wish, statistical agents or representative of StatCan to help us understand our needs and help us go forward. So I think that personal involvement is crucial to improve the data stream from the Earth observation community to NSOs. So short of us paying people to work in geo groups, the next best thing is to make sure that the conversation is ongoing. Make sure that there's a good understanding what our needs are and what the possibilities are, and also what we can do for the Earth observation world. Because when I speak to the scientists at Natural Resources Canada, they need more data to be able to build their models, their decision trees. So they need as much in situ information as possible. And sometimes that information is in a different department. They don't talk to each other, but we talk to both. So I remember our late friend Michael Bort released an article a few years ago, and it was presenting the national statistics agencies as honest data brokers. So by us bringing this information together and providing it to Earth observation and analysis groups and data generation groups, then maybe there's something for everybody. We can actually help each other.
That's me,
Ava?
right, Max?
Yep, please go ahead.
Yeah, I'm searching for the option to put up my hand, like you have it in Teams, but where is it? So please, I put up my hand, my real hand. Okay, so I think there are actually many blocking factors. Obviously, one of the blocking factors to use Earth observation data is that it's not many people who understand what Earth observation is, right? Or even able to process an image, right? You have to have a university degree on this or several years of training, and obviously it doesn't come just like that, right? Now with all the cloud processing platforms, honestly, in 5 years, Earth observation has improved so much, it changed so much that even us old old school people need to relearn the subject, right? But I think there is an even bigger problem, which Earth observation colleagues might not see, but we see it when we work with the European Union and especially with the statistical offices. I think people still don't believe in Earth observation. They don't believe that from 500, 800, 10,000 kilometer high, in the sky, that you can observe what's happening to ecosystem. There's a huge resistance in the statistical community. And I can tell you that in EU levels, there are lots of talks about naive pixel counting, as opposed to point observations, which are much better statistically, much more significant than doing naive pixel counting, right? And just an anecdote, the last thing why I think this is still indeed an issue of trust and knowing the science is, I really don't remember which paper it was, which editorial office, but we wanted to submit a paper, and they wrote back to us, and I really don't remember which one was it, that the editorial office does not accept papers where remote sensing was applied. So this is yes, it's an anecdote, but it shows, right, that there is a general non-trust in Earth observation still. I finished.
Great. No, thank you, Ava. And that is, it's a very fair perspective, and something that as a community we need to address, because it's such a powerful tool and it's critical for developing and supporting ecosystem accounts.
I'll just add, Again, some of the things I laid out in terms of making data machine readable and semantically meaningful, I think are going to be steps forward. I showed a demo for that use largely global data in an African country, but countries have their own data. And, if instead of having some of the authoritative global data sets, we also had country-specific data sets available in that machine-readable, semantically meaningful way, then platforms like Aries can integrate them and use them for more transparent reporting. The second thing I'll briefly mention is how those data are stored matters, and who pays the bill for that is something that I think many of us are increasingly recognizing. Commercial cloud has made huge inroads in hosting data, but there are egress costs associated with that, and the choices we make about how we store the data, who pays the bills, and where the data meet the models are relevant ones that I think our community needs to consider.
Maybe if I can add on what was said, I mean, I think that what do we need to move forward? I think there are two things. One, at the country level, I think it is. I mean, what areas for SEA does for us is quite important, because I mean we are able to bring countries together with some data which has already been generated, and we don't start from a blank sheet, but we have something that is there. The challenge then, it's not that is not enough. The challenge is really bringing all the institutions together and agree on the map. So this issue of that there is skepticism is definitely there, but bringing people on the table from the beginning is quite important. And I think there was a comment from Indonesia there saying, oh, we do have the data, we do have the maps, but we cannot agree to this. And I think having this standardized approach and standard concept will help to bring the stakeholders together, at least to discuss. It doesn't mean that they would have to agree, but maybe in the longer term there would be a movement in that direction. The challenge is also that national statistical offices do not have this expertise to deal with Earth observation. So they feel at the beginning, I mean, especially in developing countries, they feel completely overwhelmed. I mean, they feel we are talking a completely different language. So capacity building is also quite important. And I have to say, I mean, I have went through the same process, because I am not, I'm a statistician. I have never worked with Earth observation. So, but I think that little by little, really people will see the potential and how you can get this data, and actually how you can leapfrog countries with data poor that are data poor into something that could be useful, at least for policy making. At the global level, I mean, sitting where I'm sitting, I think that what we would like to do is trying to scale this all up. So not only in terms of having agreed methods for measuring the extent accounts and the ecosystem services. So that would be 4 different ecosystem types. So building on the expertise which is already there. And also, I think in terms of the platform, I mean, I'm not sure whether I should be concerned or not. We all said, oh, there are so many platforms, and I mean, it's fine as long as then they are interoperable. I mean, I am not sure. I mean, coming from a statistical perspective, I think ideally we would really like to have things that are standardized. I mean, at least from the SEA perspective, I sometimes feel that it's like really a waste of money, that there are so many platforms that have more or less the similar objectives, and I cannot understand why we do need so many platforms and why we are kind of spending so many resources on this. Thank you.
Eva, go ahead.
Yeah, thanks. And on the what a difficult word, standardization that Alessandra has just mentioned. Another anecdote I can tell you, and I want to tell you, is that once we talked to FAO and the Food and I lost FAO in Rome, right? And they said
agricultural organization.
Yes, thank you. Sorry, of course, Food and Agriculture Organization, right? And they told us that obviously they were not Earth observation people, that you guys, each time you color a map, there is a different color, and you always have a different result. So that is indeed standardization, right? Which because I think we have to increase credibility, and increasing credibility is using interoperable data, standardized data, and that we follow the FAIR principles, right? The statisticians have trust and credibility in us. But again, it goes back to what Alessandra says, that standardization, especially in accounting, that you have to account for area, right? It goes down to what projection system you use, right? Because a lot long you can't use, because you can't calculate area with that. But indeed, standardization is extremely important, that once we report Europe is 6 million square kilometer, it stays 6 million square kilometer, because even if we say the next time that it's 6.0001 million square kilometer, a statistician won't say, oh, that's peanuts, that difference. A statistician and many other people will say there is a difference. You don't know what you're talking about, no matter how little the difference is, you see. But that is the issue which causes non-trust. And then you can start talking to people, yeah, but we have different spatial resolution, they don't overlap vector and raster. No, as soon as we start, justifying our science, we lost. And that is why standardization is extremely important.
That's a great point, Ava, and I think that it resonates. I know with everyone on this panel, but also it seems like from the question and answers in the comments as well. One of the comment or the questions that's been coming through the chat and coming through in the comments is this idea around uncertainty, and how do we as an Earth observation community document uncertainty in a way that can be most useful for statistics. And I think both communities have a long history of documenting and measuring uncertainty. I'd maybe turn this to the panel on how can we do better about being clear about our uncertainties, and also making sure that the uncertainty that we're measuring is relevant for ecosystem accounting. It looks like, for example, in the chat we have some, how is it captured in the Aries platform, or how do we incorporate that? But also, from Francois' experience in compiling accounts, that needs to be accounted for when you're developing official statistics. So maybe I'd reflect on the panelists on the question of uncertainty.
If I may, I actually don't have an answer, but for sure, especially if we're talking about measuring the extent of ecosystems, the uncertainty associated, and Melody points to it in the chat, for many of the categories, it will be difficult to actually measure change in extent without any doubts, right? It will be a lot of gray areas. So for some ecosystems, it will be difficult to track change in extent with certainty. But short of that, and maybe more importantly, though, it could measure. We will be measuring the condition of these ecosystems using a variety of indicators. So we might not know if the forest is for sure some specific types of forest is changing, but we would be able to report on it using canopy cover or whatever other metric we have access to. So I think we have to be clear on the levels of uncertainty. We have to be clear to not go beyond what the data allows us to support, but we also have to be imaginative and use complementary information to help address issues that are not addressed because of uncertainty. So there's a lot of analysis that is involved. How's that for a non-answer?
Perfect. Any other thoughts from the panel around uncertainty, or how do we build uncertainty into or how can we be transparent about our uncertainty as we move through the data supply chain?
Well, I'll just echo Francois' points briefly about making sure we're detecting real change and looking at spatial and temporal autocorrelation, which can occur with some of these data sets. There are emerging ways to do that better and better. And I think, honestly, that's kind of the next step for the SIA community. We've been brought on board with these geospatial tools and data sets, and now we also need statistical techniques to show what change is actually happening in a significant way. I think that's something that we need more involvement from the geospatial community in doing for the next generation of SIA.
Great, thank you, Ken. And yeah, I think that is definitely a rallying call for the GEO community around, kind of meeting together and co-developing these products so that they can be fit for purpose.
Yeah, and the statistical community is really not used to deal with change, with uncertainty. So we never do. So it is very much a learning curve and a capacity building things that we need to address.
Great. So going through the chat and the Q&A. One question that jumped out at me that's quite interesting is, the SIA is inherently a government-led process. National statistics are a government-led process. And I'm curious from the panel's perspective, is there a role for private entities to participate in the SIA, either as data providers or as users of the information from the SIA? And what does that look like, that balance of bringing in private entities or private geospatial into SIA accounting or working with the SIA accountants?
If I may, and I may have a better answer next year or the following year, but we're just discussing the external advisory committee for our initiative here, and we agree within our group that we need to bring in some specific private interests, business interests, in order to be representative of the different uses that this can be put towards. Now, there's the whole world of environmental non-government aid organizations, but there's also business interests that have that draw from the land and have an impact on the land, and we want to find a way to bring them on the advisory committee so we can understand their needs and make the best use of the data that we're putting together. So it's not really an answer, but we recognize the need to do that, and we accept it.
But also, I guess it depends on what data we're talking about, because if you're talking about statistical data in sensu stricto, I mean, who else is better to provide statistical data than national authorities, right? But if you're talking about Earth observation data, we must engage the private sector. We have internally also had this discussion once. The entire Earth observation science has changed. It used to be universities that provided data, right, and made them available. Now it's the private sector, because these people, I mean, it's companies who have the capacities to process the data, Earth observation data, on big cloud processing infrastructures, and put out data which we can use for accounting. But then again, and this is again what Ken talked about, all these data have to be interoperable, and it's not enough that you can download it manually from somewhere, right? This data have to come in a way that machines can access them, right? And that we can use them directly in our accounting system. But again, it's not universities anymore, although I'm not talking against science, right? Science, the basic science is there and is very important. But when it's about spitting out the data and bringing it in, I think the private sector is very important.
I'll just add quickly, for building on the great points that Francois and Eva already made, that I think there are definitely important roles for the private sector. We have a paper that'll be coming out hopefully early next year about private sector engagement with natural capital accounting in the United States, and sort of see business as users of the information for compiling private sector natural capital accounts to help their management, as potentially providers of data, and not just satellite data. In the US, we've developed land accounts using data from Zillow, and national statistical offices, at least in the US, are in some cases more and more turning to private sector data sources and partnerships with the private sector over traditional survey methods, and also in shaping the development of what accounts need to be built and in order to inform business and sustainable management of natural resources. So 3 ways that businesses could engage. And in thinking about interoperability, I would just add that the vision I presented was very much inspired by the open source community. So let's make everything as open as possible, and that's great for scientists. But in terms of engaging with business, I think any way business, private sector efforts can meet even a part of those interoperability standards is helpful. They may not make their software or their algorithms public, but if they can make data public, if they can contribute to the development of semantics, things like that, those are real steps forward and ways for the business community to contribute.
Yeah, I mean, I think if I can add, I fully agree with what was said. We also do have a group within the SCEA community to bring together also the business sector, and exactly what Ken was saying more. I mean, looking in particular at how the businesses can use the SCEA thinking, I would say, for organizing information at the business level. Also how they can foster this collaboration with national statistical offices and see what the data that is already available, especially contextual data that usually they don't collect, so that it helps for the businesses. And then the objective really here is trying to harmonize and develop a business accounting for environmental component, which is aligned with the SCEA. So this would then allow the statistical offices to collect data that is already organized by the businesses according to the definition and classification that we use in statistics, and that would facilitate that. So that is more, I think, for on the use side of the businesses, or also on the provision of information to the national statistical offices. Then I think that there is this whole discussion of the private sector, what Eva was referring to, of making data available for use for accounting purposes. And this makes things a little complicated for us because, I mean, we have to be able to provide data to developing countries that do not have really resources to pay for this, for the data. So, and how can we actually make this data available in a way that that developing countries can also benefit from it without paying. I mean, after all, we are providing a global goods, but the business model is slightly different. So we are a little bit in a bind here.
I mean, that's great. It's great to hear all the different perspectives, and it sounds like this public-private interaction might be a rich area to dig into, and GEO may be a good place to discuss this, especially from the Earth observation perspective and understanding how private industry can contribute to the development of accounts. I'm cognizant we only have 5 minutes left, and I thought that maybe we could end with a little inspiration. Throughout all the presentations, one other common thread that came through was how ecosystem accounts can provide kind of a unifying framework for helping us to achieve, the ambitious, development, climate, environment, and human well-being goals that we've set out for ourselves and our world, I suppose. And maybe I would just ask the presenters if they could reflect on where you think that opportunity, where you think the greatest opportunity for this is, so that we can link in with some of the GEO priorities to use ecosystem accounting to help support our larger global mission. And that can be across many of the different areas in which GEO works. As one of the things that we hope to generate out of this side event is greater collaboration across GEO initiatives, because we're doing so much great work. How can ecosystem accounting provide that common thread that connects the work that GeoBot is doing with the work that's being done around urban resilience, for example, or being done to address climate change? So I'll open it to the floor to the presenters for some final reflections.
I think I kind of presented this vision that for us, basically the SEA would be the underlying statistical framework that would then inform all the different monitoring frameworks. And this would mean that there should be like a kind of a partnership or collaboration, give and take, between the different, the work that is being done. And we are now approaching it more kind of on an ad hoc basis, let's say. We are talking to GeoBon to see what they're doing and how we can use the information that they are developing into, for example, areas for SEA to compile the accounts. And I think it should be both in terms of receiving data, but giving back data, and then developing, co-developing, I think, also this indicator part, which I think, can I show that we have tried to put some of the indicators there more for illustrative purposes, but then eventually, the whole objective is to integrate the basic data and then develop indicators. And I think even in the next few years to develop maybe some type of scenario analysis that can support policy making.
I would also like to add something. Thank you, Alessandra. I'm not sure how to formulate, but I want to say, obviously we can't stop development. We can't stop universities and private industry to produce data, right? In Europe, we see a huge amount of data coming out from NGOs and universities, and we have, I don't know by now how many land cover maps, right? All on different spatial resolution, different hierarchy, different classification. What is forest, for example? It's not such an easy issue to define what is forest, what's the canopy cover you have to address, right? But this data is all there, out there, and depending, we have done the test, depending which input data you use, you might have entirely even opposing trends of increasing or decreasing area, right? How are we going to do accounts like this? So hence why you can't stop development and can't stop people to put out all this data. I think it is the responsibility of national authorities, statistical offices, or governments to decide this is the data which we're going to use, nothing else, and this is the indicator which we are going to use, because maybe the absolute value is not correct, but if you don't change the input data, if you stick to this indicator, at least the trends which we monitor are stable. You know what I mean? So this is, again, back to standardization, but it's also, putting your face out there and to say, this is the data set we use. And we appreciate science, we appreciate development, but at some point we need to start reporting what is wrong with our environment, because we talk, it's bad, but we need to report and we need to pinpoint this area there you don't seal any soil anymore, here you don't use groundwater anymore, etc., right? I'm not sure if I managed to put this. It's into clear word. It's still a feeling I get maybe at the next GEO event I will be able to be more clear. But I hope it was more or less understandable what I wanted to say.
I'll just add that this interoperability question is a broader question across GEO, of course, and we're very happy and fortunate to be working on it within the SIA space and with UNSD and many others as partners on it. But this was pointed out in GEO's midterm evaluation that interoperability is a challenge for a range of GEO initiatives and connecting data across them. And I'll give one quick example that at USGS, we of course have a very broad mission dealing with geology, geography, water, ecology, natural hazards. And we've been using the ARES framework to work on some earthquake and drought hazard models, which are not intimately tied to ecosystem services, but for which the interoperability and integration framework can still apply. So I think there are lessons for the GEO community more broadly in that too, which we're excited to continue to carry forward.
I was going to say that I totally agree with Eva and what you mentioned. What I think we can, and to chime in on what Ken just said, the work that we're doing is generating authoritative baseline national, subnational information that is agreed or understood by the different departments in a given country. I'm talking from Canada's perspective. Now, private interests, other data sources may disagree with our numbers, but at least they have something to disagree from. So if only putting those numbers that are authoritative and that are baseline information, then they can, there's so many variations that can be then brought to this information to picture any other type of information they want to try to communicate. But the goal is to provide apolitical, honest information that is just a starting point for the rest. And yes, accounting is super important, and we certainly support all of that. But like Ken mentions, there are other applications of this information that go beyond accounting that can be central to risk management, but also security and emergency preparedness. And I'm looking at what's going on right now in the interior of British Columbia and the floods that are ongoing. Now, we need to be able to cater to these events sooner, and that can only happen if there's a good relationship between national departments of various kinds and the global Earth observation community, and GEO in particular, I think.
Great. Well, thank you, everyone. Thank you to all the panelists for presenting and for providing your perspective. And thank you for all of the audience members. It was a lively chat and QA session, and we really appreciate you kind of coming here and spending time with us. And we hope to continue this conversation within the GEO community and within our various networks and bringing people together. That's ultimately the goal of EO3A, is to bridge the accounting community and the Earth observation community so that we can have meaningful impact on our planet. So thank you all so much and enjoy the rest of GEO Week. Bye-bye.
Thank you. Bye-bye.